So we have 6n to the third, we have 3n to the fifth. So we want to think about what number and what variable do they both have in common to the highest degree. Okay, so when we're looking at greatest common factor, we're looking at what greatest number and greatest variable do they have in common at the same degree. So Justin, I saw your hand first. 3, so that's the greatest number, but what else do they... Try to be a little more thoughtful here.
Yeah, I've seen pencil right there.
Okay, try to be thoughtful there. Okay, and then also what variable to what degree? Okay, so n, and then Joe, you said n to the third, right? So again, we're trying to think about what number and what variable to the highest degree. So essentially what you're doing is you're dividing both of these things by 3n to the third. So for this first one, if we divide it, we can take out all of this, and to get from here to there, what is that number? So essentially if you divide 6n to the third and you divide it by 3n to the third, what are we left with? Right, 2. So in parentheses, we're going to have 2. And if we divide our second 3n to the fifth, what are we going to have left over? So technically it's sure 1. So make sure you always keep your negative unless you're taking out a negative. And Joe, yes, it's going to be n to the second power because we're taking out 3 n's, right? But we have 5 here, right? We have 5 here, so we're left with 2. You can write it in this way. I do prefer that you write it in this way, just so it's less work for yourself. Okay. Okay, but good job. So this is a basis, this is the foundation, or this is the first thing you have to know. If you don't know how to do this, you won't be able to do grouping. All right. Okay, so I'm going to go to I guess let's do an easier one. So let's do number 1. So this is, again, this is the basis for what we're doing for grouping. So now for grouping, it's going to be 12a to the third minus 9a to the second plus 4a minus 3. If you are interested in honors, for honors, what they'll do is they'll give it to you in a different order. They won't necessarily give it to you so that it's always the first 2 and the last 2. So they might actually give it so it's actually the first and third, and it's actually the second and fourth. So just be careful, or it actually might be first and fourth and second and third. So if you want to be interested in honors, they're going to make it so you have to actually analyze it and then just determine which one are you actually going to group together. Okay, just something food for thought. Okay, so generally I will say for these ones, we will group them by the first and second one. So we're going to group them like this. So generally for these ones, you're going to group them like this. But again, for honors, eventually for honors, they will not group them first and second, third and fourth. Okay, they'll make sure that you're more creative. Okay, so for this one, I just want to look at the first 2 terms. What is the greatest common factor, or the biggest thing I can take out from both of them? Right? Not just the biggest number, but also the biggest variable. So looking at the first one, what is the biggest number and variable I can take from both? Okay, so Trevor, I'll call on you in a sec, but I just want you to think about this. So we're looking at 12a to the third minus 9a to the second. What is the biggest number and variable here? So Trevor, you can go for it.
3a squared.
Right, 3. So 3 is the biggest number, and then a squared. So we can divide both of these by 3a squared. So Joaquin, what would the first term be? So if we're taking out 3a squared, what would the first one be?
A.
There is an a. What else is there?
A to the third.
So if you're taking out a squared, how much is left? Just one a, right? But what else is left?
Oh, minus 9a to the... Wait. Oh, my bad. Plus 4a.
Right, 4a is left. So essentially what we're saying is that 3a squared times 4a is equal to 12a to the third, right? These two multiplied equals the first term, right? So that's, we're breaking it down. And then so if we take 3a squared from negative 9a squared, what are we left with there? So essentially what you should do is you should divide this, or take out a squared, and also take out a divided by 3. Justin?
Negative 3a.
Right, you have to make sure to keep your negative, so I appreciate that. And you said negative 3, and that's it. So again, this is how we break down the first term. Okay. So now we're going to look at the second term, and what you can see here is you should see that these are exactly the same, and that's a good sign. That's a good sign you're on the right track. So for this, it looks like there's nothing in common with 4a and negative 3. But I want you to think hard because a number can go into any number. And what number is that? What number is that? So what number do they have both in common? What number do they both have in common? So just try to think about a number that can go into any number. Okay? And then... Right, it'd be 1. So thank you for both people who answered. So it'd be 1, right? 1 goes into any number. So 1 times 4a to the negative 3. Okay. Okay, so the reason we do this, and this is really going to be really important in Algebra 2, is that both of these things are multiplying exactly the same thing. This is what we want to get to. We want to get to the point where both of these, the greatest common factor, is both multiplying the exact same thing. Okay? So if you get to this step and you have two things in parentheses and they're not matching, you've done something wrong at this point. Okay? So just make sure that at this step, both things inside the parentheses should be exactly the same thing. Okay? If they are multiplying the same thing, we can actually combine these two into one parentheses. And this becomes 3a squared plus 1. So this is going to multiply 4a minus 3. So these are going to become this. Okay. So whatever was inside the parentheses actually combines, and they just become one thing right there. The reason we're able to do this is actually because of the previous lesson that we did, the previous chapter, which is that if we multiply things out, we would multiply 3a squared times 4a, so 3a squared times 4a, and then we would do 3a times negative 3, right? So if we were to distribute this back out, we would get 1 times 4a and 1 times negative 3. And you can see that, again, if we're multiplying this out, we're actually going backwards, right? So I'm just showing you what's happening here. If I were to go backwards, you can see that if I were to distribute each of my terms, I would go backwards to this previous step, okay? So I'm actually, instead of going out from multiplying, I'm trying to bring everything back together. I'm trying to go back to the original signs, okay? So technically, on the test, I just want you to end right here, but I just want to show you mathematically the reason we're able to do so is because we're actually distributing, so we're undistributing all of our different terms, okay? The reason we're able to do this and the reason why this is so important is because if you look at this, what it's saying is that you have an area of 12a to the third minus 9a squared plus 4a minus 3. So imagine you have an area inside a rectangle and you want to determine what the sides are. If you don't know the measurements of the side, you can actually, by factoring and by grouping, now we know one of the sides is equal to 4a minus 3, and the other side is 3a squared plus 1. So what we've essentially done is we've found the length and the width of that shape, and we went from the area to the length and width. Okay? So mathematically, that's what we're doing here, is we're actually finding the area, starting with the area, and going backwards. Okay? We're going backwards. If that did not make sense to you, that's okay. I just want to help you to understand mathematically what's going around in the background. Why are we doing this? And again, this is an essential skill later on, because then we'll talk about how do we maximize the area. So if you're trying to build a structure, now you can think about how do I maximize the amount of area? What's the best sides that I should have to create the best building, which has the biggest and largest amount of sides, right? Or the biggest area. You can also take away sides and then still maximize areas, and you could talk about, you can figure out what the length of each size is based on the area. So that's kind of essentially what we would work towards, right? These are just the basic foundational skills. Okay. Eventually you could find the maximum, or you could find the best volume, or the best volume of, you know, a shape of a sphere, of a rectangular prism rotated around a certain object. So that's the end goal, is that you would even have objects rotated around other objects, and you would find the maximum area, or the volume, sorry. But it's okay, we're focusing on this. All you really need to do is to group. So all you want to focus on is getting the greatest common factor. Then you want to put them together. That's it. Find the greatest common factor, put them together, and that's your end result. That's your answer. Okay? Okay, so we'll talk about this again, but I want to focus on the last problem, or not the last problem. I want to focus on the last type of problem. So we have x squared minus 11x plus 24. And it tells us to use the x method to solve this, right? It tells us to use the x method to solve this. So when I say use the x method to solve this, you're going to draw an x. You're going to draw an x. Okay? Okay, so after drawing the x, what we're going to do is we're going to fill in the top and the bottom of the x. Okay? So for the top number, you're going to actually put the c, or you're going to put 24. And for the bottom number, you're going to put b, or negative 11. Make sure that you keep all of your signs. So make sure you keep all of your signs. Okay, so after you have done so, what you want to do next is you want to find the same two numbers, which when multiplied equals the top number, while when they're added together equals the bottom number. Okay, so I'm going to say this again. So on the sides, what you're going to do is you're going to find a pair of numbers that when multiplied equals 24, but when added together equals negative 11. Okay. So you want to think about, if you're not sure, you're having a hard time with this, you can think about the factors of 24. So for 24, you can break it down into 12 times 2. You can break it down into 6 times 4. You can break it down to 8 times 3. You can break it down to 24 and 1. And I believe that's all of the factors there. Right? So you want to think about which of these numbers, when you multiply, equals the top number, but when also added together equals the bottom number. Okay, Reese? Oh, sorry. Let's go a little more that way. Thank you. Joaquin? Right, so you can think about 8 and 3, right, when they're multiplied equals 24. However, when they're added together, they don't quite equal negative 11, and so that's why we also need the negatives. And so when they're added together, a negative plus a negative equals a bigger negative. So what you do after this is that you actually put them as factors. So you do x minus 8 times x minus 3 equals x squared minus 11x plus 24. And if you're confused why we're able to do this, again, we're going from our last chapter, and we're actually starting with the area, and now we're going back to the sides. So I'll just show you that if I were to multiply this out, this would be x times x plus x times negative 3, and then, minus 8 times x, and then minus 8 times negative 3. This would be x squared minus 3x minus 8x plus 24. And then if I add it together, you can see here that if I redistributed or remultiplied everything out, I actually go back to the original answer. I go back to the original answer. So you can see here that I'm actually starting with the area and going back to the sides, as I said before.
What's the answer?
So the answer here would just be x minus 8 times x minus 3.
Oh, I see.
Okay. So again, the reason I wrote the rest of this is to just show you that if I multiplied it out, I actually get back to my original answer. I can go back to my original answer. Okay, so that's a way you can check your work. If you feel like you factored it incorrectly, you can multiply them out and go back to your original answer.